Hello everyone. We are still under coordinate geometry, but today we are looking at angle between two straight lines. So we are going to consider xy plane. We consider xy plane. We will have xy plane. So this is x-axis, and here is what? Y-axis. So we are going to consider line. We consider the straight line AB. Then we are going to consider another straight line CD. So we consider another straight line CD. Then here now, the angles between line AB to the x-axis, we call this alpha 1. And the angle between line CD to the x-axis, we call it alpha 2. Then the angle between the two straight lines is alpha. Then if you now look at this, you can see that two intersection of line, then the opposite angle there are the same. So alpha here is equal to the alpha here. So to connect these three angles together, it means the angle between line AB and line CD is what? Alpha. And to do this, we are going to introduce gradient of line AB. So gradient of AB is given as M1, which is equals to tan alpha 1. The gradient of line CD, gradient of line CD to the x-axis is given as M2, which is equals to tan alpha 2. But remember that alpha plus alpha 1 equals to alpha 2. That is, exterior angle is equal to the sum of interior opposite angle. So, since we are looking for alpha, it's now going to be alpha equals to alpha 2 minus alpha 1. So, alpha 2 minus alpha 1. That is our what? Alpha. Now, the gradient of alpha will now be ordinary f. But remember that the acute angle, okay, since tan alpha is the same thing as tan alpha 2 minus alpha 1. So this is the gradient f equals to tan alpha, which is tan alpha 2 minus tan alpha 1. We can now see the acute angle. If you look at this, this is an acute angle, that is the angle less than 90 degrees. So this alpha is less than 90 degrees. So you now have it as the acute angle between the two straight lines, is given as tan alpha. And what is tan alpha? Tan alpha is the same thing as tan alpha 2 minus alpha 1. So what is tan alpha 2 minus tan alpha 1? So we have tan alpha 2 minus alpha 1 equals to tan alpha 2 minus tan alpha 1 all over 1 plus tan alpha 2 tan alpha 1. Since we are writing this in terms of gradient, it's now going to be tan alpha 2 is what? Tan alpha 2 is M2 minus M1 all over 1 plus tan alpha to that is m2 m1. So that is that on the tan alpha 2 minus alpha 1. So which is the same thing as tan alpha. So the angle between the two straight lines, which is alpha, then tan alpha is equals to m2 minus m1 all over 1 plus m2 m1. So that is that on the what? On the gradient. But if m2 minus m1 all over 1 plus m2 m1 is less than 0, so what will happen? So we are going to obtain the obtuse angle. So we obtain the obtuse angle obtuse angle 180 degrees minus alpha. That is when m2 minus m1 is what? All over 1 plus m2 m1 is less than 0. So we are going to obtain obtuse angle, and the obtuse angle will be 180 degrees minus what? Minus alpha. So therefore the angle alpha between, therefore the angle alpha between the two straight lines is given as tan alpha, which is our absolute value of our modulus of m2 minus m1 all over 1 plus m2 m1, then those the absolute value. So in this case, when our summing here is minus, this absolute value will take care of the minus, it will change it to positive value. So the angle, the formula now, that for the angle between two straight lines is given as tan alpha equals to absolute value of m2 minus m1 all over 1 plus m2 m1. So that is that on angle between two straight lines. So we are going to the first example now. Example on the angle between two straight lines. So the question says, find the acute angle between the straight line y equals to x and y equals to what? Root 3x. So what we are going to do, our aim is to bring out the gradient from the first equation and the gradient from the second equation. And you should remember the angle between two straight line formula. And the angle between two straight line formula is tan alpha, which is absolute value of m2 minus m1 all over 1 plus m2 m1. So here is the formula. So m2 will be the gradient of the second equation, m1 will be the gradient of the first equation. So for the first equation, y equals x. So if we compare this with ns plus c. So the gradient here is m, which is the coefficient of x. Then the gradient here is what? Coefficient of x. And the coefficient of x is what? 1. You can now say m1 equals 1. And for the second equation, y equals square root of 3x. So we compare this with ns plus c. So the gradient here is m, while the gradient here is root 3. So m2 equals to root 3. Then after this, we now substitute m1, m2 into the equation given. That is tan alpha equals to absolute value of m2. m2 is root 3. So root 3 minus m1, that is 1, all over 1 plus m2 m1. m2 is root 3 multiplied by m1, that is 1, close the bracket, then close the absolute value. So which is equals to, at least tan alpha equals to absolute value of root 3 minus 1 all over 1 plus root 3 because 1 multiplied by root 3 or root 3 times 1 is root 3. So the next thing to do is to rationalize the sum. So which is equals to absolute value of root 3 minus 1 all over 1 plus root 3 multiplied by. So look for the conjugate of the denominator, and the conjugate of the denominator is 1 minus root 3 all over 1 minus root 3, and close the absolute value. So which is tan alpha equals root 3 multiplied by 1, that's root 3. Root 3 multiplied by minus root 3, that is minus 3. Minus 1 times 1, minus 1. Minus 1 times minus root 3 plus root 3. Then all over 1 times 1, that is 1 minus root 3 plus root 3 minus 3. Close the absolute value, then open another absolute value. Then root 3 plus root 3, that is 2 root 3. Then minus 4 all over 1. Okay, root 3 cancel root 3. That's minus root 3 plus root 3 is 0. Then we have 1 minus 3. That is minus 2. So minus 2. So we now have tan alpha equals the common factor here is 2. So absolute value of 2 into root 3 minus 2. Then all over minus 2. Close the absolute value. We have 2 into 1, 2 into 1. So you are left with absolute value of minus open bracket root 3 minus 2. Close the bracket. So absolute value will take care of the minus. So you'll be left with alpha, which is equal to root 3 minus 2. So which is tan alpha equals square root of 2. Square root of 3. Okay, we can still keep this absolute value. So square root of, if you keep the absolute value, you can write this as minus times log, that is minus root 3 plus 2, which is the same thing as absolute value of 2 minus root 3. So if you have this, it's now going to be 2 minus square root of 3. Square root of 3 is 1.732. So tan alpha will now be 2 minus 1.732. 2 minus 1.732. So the answer is 0.268. So we now look for the time inverse of 0.268. So we have alpha equals to tan inverse of 0.268. So alpha will now be, alpha, which is the angle between the two straight lines. Now press shift tan of 0.268. That is 15.003 degrees. So alpha will now be 15 degrees. So the angle between the two straight lines, y equals to s and y equals to square root of 3s, is given as 15 degrees. So that is that on example 1. So example 2 says the angle between the positive horizontal axis and the given line is 135 degrees. So find the equation of the line if it passes through the point 2, 3. So what we are going to do here, we are given angle of slope to be 135. So alpha, solution, alpha is given as 135 degrees. That is obtuse angle. Find the equation of the line if it passes through the point. So we have point x1, y1 is given as 2, 3. But remember, the formula that connects alpha and the gradient, because we are going to need the gradient to look for the equation of the straight line. So in fact, the equation of the straight line we are looking for is in the form y minus y1 equals m into x minus x1. So we know our x1 y1, but we don't know the gradient. And to get the gradient, we are going to make use of m equal to tan alpha. That is tan alpha equal to the gradient. So m is the same thing as tan. So if you could remember, in the proof of the angle between two straight lines, so once you have obtuse angle, it's going to be 180 minus alpha. So 180 minus alpha is going to be m equals to tan 180 minus, our alpha is what, 135. So 135 degrees. So which is equal to tan, so tan 135 degrees, 180 minus 135 is 45 degrees. So we now have m equals to tan 45 degrees, tan 45 degrees. So let's tan 45 degrees is 1. So 45 root 2, 1, 1. So opposite over adjacent, that is 1. So tan 45 is 1. So you can now go back to the equation of the straight line that says y minus y1 equals to m into s minus s1. So which is y minus y1 is 3. So which is m gradient, that is 1 into s minus 2. So we have y minus 3 equals s minus 2. So y equals to s minus 2 plus 3. So y equals s plus 1. So that is that on the second equation, on the second question. So the equation of a straight line which passes through the point 2, 1, and the angle of slope is 135 is y equals to s plus 1. So that is that on angle between two straight lines. Thank you.